In this lesson, we're going to continue where we left off yesterday talking about simple interest, and we're going to build towards understanding how compound interest works. So just to be clear, the difference between simple interest and compound interest is that when you use simple interest, an amount of money is put aside for a certain amount of time and builds interest on the original principal, the original starting amount. Compound interest is when you build interest not only on the original principal, but also on any previously built interest. So interest on top of interest is where compounding comes in. That's going to be the focus of tomorrow's lesson. Today we're going to build towards that idea, but we're going to just use the simple interest equations. So yesterday we saw three equations, two of which we actually kind of used. We used our I equals PRT equation, and we used our A equals P plus I equation. And then there was a third equation, the A equals P times 1 plus RT, which we didn't really use but was there. And what I'd like to start by doing is just showing you that that equation is not actually a different equation or a new equation. It's just a modification of the two equations we know so far merged together. So if I start off with A equals P plus I, and then I remember that I equals PRT, what that really means is that A equals, that's the messiest A ever, but A equals P plus, and rather than write down I, I'm going to write down PRT, since that's what I is equal to. And then there's a skill that we often forget about in math called factoring. And basically it says if a certain number is a multiple of every term in a expression or an equation, we can factor it out. So in this case, both P and PRT have a P in them. So I'm going to pull out the P, and that leaves us with 1 times P in the middle, plus RT times P, which gives us the PRT. And that is what you'll see is the original, or the other equation that we want to work with. Now, I do want to point out that my handwriting, sometimes most people think it's hard to tell, is that an I or is it a 1? My handwriting, I will try to be very obvious. My I's are almost like sideways H's. I really emphasize them, whereas my 1s are usually just straight lines, just so that it's clear which ones are I's and which ones are 1s. So let's see how this works with our new equation. Question 1. How much would you have in a bank account where you invested $300 for 4 years at 6% a year? So the first part here is saying, how much would you have in a bank account? Now this is assuming that you're talking about at the end of the investment, and that's our A value, our accumulated amount. And since it's asking us how much we're going to have, that's our unknown, that's our question mark. We're investing $300. That's going to be our starting amount or our principal. For 4 years, so time equals 4, and 6% a year, so R is 6%, which is 0.06. Now looking at the variables that we've got and want, we have an A, a P, a T, and an R. And there's one equation that has all 4 of those variables and no extras, and that's A equals P times 1 plus RT. So there's our new equation. Now from there, plug in the things you know and leave the things you don't know as variables. So we'll leave A as A. P is 300. 1 plus 0.06 times 4. Now just to be clear, we got to make sure that we're using BEDMAS here, which says we got to do the bracket before we multiply the entire bracket by 300. And within the bracket, we have an addition and a multiplication, and we have to do the multiplication first. So when I do that multiplication, 0.06 times 4 is 0.24. And now I add those together to get 1.24. And finally, I just do 300 times 1.24, and I get $372. So what that means is if I invested $300 for 4 years at 6% a year, I would eventually have $372. Now, I can also logically figure out that I must have made $72 in interest since I started with $300, but this is a way of getting the amount that I have at the end in one step. Example 2. How long would you have to invest $800 in order to have $1,000 if the interest rate was 4% a year? So we're investing $800. That's a starting amount or a principal. We want to have $1,000 at the end, so that's our A. We're told the interest rate is 4%, which is 0.04. And we're asked how long would we have to invest. So what that's really saying is, what's our time for our investment? Okay, same as last time. We look at those variables and we say PART. That looks like all the variables in the equation. A equals P1 plus RT. And now we just plug in the knowns and leave the unknown as a variable. So this is 1,000 equals 800, 1 plus 0.04 T. All right, now we have an equation that we have to solve for T. Unfortunately, this is going to be a couple steps, but remember the goal of solving equations is just to get T by itself. So in order to get T by itself, what I'm going to do first is divide both sides by 800. So on the left, 1,000 divided by 800 is 1.25. And on the right, when I divide by 800, the 800 on the top just cancels with the 800 on the bottom, and I'm left with 1 plus 0.04t. Now to get t a little bit more by itself, I'm going to subtract 1 from both sides. So I've subtracted 1. And on the other side, I'm left with 0.04t. And in the final step, I'll divide both sides by 0.04. So 0.25 divided by 0.04 equals 6.25. So to be technical, I should write down 6.25 equals t, but I'm going to write down t equals 6.25 since the order doesn't matter. So that means that I have to invest for 6.25 years in order to take my $800 up to $1,000 at a 4% interest rate. Okay. So now what we're going to do is take a look at an investment. Now we're going to invest $1,000 into account for 5 years at 40% interest per year. I'll point out that 40% interest a year is crazy high. Like unless you're dealing with loan sharks, 40% interest is, or actually like payday loan places, but they're basically loan sharks anyway. You're not going to see interest rates like this. 40% is super, super high. I made this 40% partially so that you can see the effect of compounding versus simple interest, and partially because it gives us nice numbers to work with. Mostly because it gives us nice numbers to work with. So here's 2 ways we can make our investment. I can take my money and I can invest it for 5 years and not touch it. So that's just a normal simple interest. And let's see what happens. So A equals P, 1 plus RT. And oh, I forgot to put my variables at the side there, so I'll just do them over on the right-hand side. We're investing $1,000. Time is 5 years, and the interest rate is 40% or 0.40, but the O doesn't do anything, so just 0.4. And we're trying to solve for how much we're going to have invested at the end. Okay, so that gives us A equals 1,000, 1 plus 0.4 times 5, which is 1,000 times 1 plus 0.4 times 5 is just 2, which is 1,000 times 3, which is $3,000. So if we took our money, put it in the investment using simple interest, and just left it there for 5 years, we would eventually have $3,000. Now what we're going to do seems like a ridiculous thing, but again, it's just for an example to kind of build towards compound interest and how it works, is we're going to put our money into the investment, and then what we're going to do is come back every 6 months, take our money out of the investment, including the interest we've made, and then put it back in as a new principal. I know that seems like a ridiculous thing again, but just bear with me and let's see what happens. So just like last time, we're starting with $1,000, and we can find the amount that we'll have accumulated by setting it up as A equals P times 1 plus RT. For now, I think I'm just going to leave that second table or the second column of the table blank. We can come back to that later. And it's basically just telling us how much interest we made during that time. Okay, so we walk into the bank or whatever it is on the first day at time 0 and say, here's $1,000 I'd like to invest. And then I come back 6 months later. And the amount that I'm going to have after 6 months or 0.5 years is going to be equal to 1,000 times 1 plus 0.4, which is the interest rate, 40%. And the T is just going to be 0.5. It's half a year. And that simplifies down to 1 plus 0.4 times 0.5 is 0.2. So this is going to be 1.2. And that's 1,200. Now, the good news is we're going to actually speed this up a little bit as we go, and you'll see why. So we take our $1,200 out of the bank. Incidentally, we have made $200 interest. I'll fill that in there now because it's easy to calculate. We put in 1,000, we took out 1,200. And now what I do at 6 months is start a new investment. And I'm going to invest it again for another 6 months, which takes us up to the full year. So as it turns out, the interest rate, the R, doesn't change. And the time also won't change. It's also going to be for 0.5 years. So what ends up happening is the only thing that changes is I put in my new principal and I multiply it by 1.2, the same number that I multiplied by originally. And when I do that, I get $1,440. Now again, if I put in 1,200 and I take out 1,440, I think it's pretty clear I made $240 in interest. Should put dollar signs on these answers just to be technical here. So now the nice thing is I actually made more interest during the second 6 month block than I did during the first 6 month block, because technically I'm building interest on the original principal, but I'm also building it on that extra $200 of interest that I already made. So now to go down the line here, I do the same thing. I've taken the 1,440 out and I reinvest it. So it becomes my new principal. And it gets multiplied by 1.2. And now's where we got to put the numbers in the calculator because it's going to get a little bit trickier to keep track of. So 1,440 times 1.2 is 1,728. Now, I'm not going to bother trying to fill out the second column yet because it's starting to get a little bit more complicated. But from here, what I'm going to note is that now I just take that new number as my new principal, invest it for half a year, so 1 plus RT is still 1.2. And now without clearing my calculator, I at no point from here on in will clear my calculator. I take 1,728 multiplied by 1.2, and that gives me 2,073.60. And now I multiply that by 1.2, and then I'll multiply that by 1.2 and so on. So I'm going to stop writing out the beginning part. I'm just going to take the 2,073.60 times 1.2 and write down the answer, which is 2488.32. I'm going to multiply that by 1.2, which is 2985.98. And I should point out at this point, I'm now at a little bit extra that I'm rounding off. It was 0.984, so 98.4 cents. I'm only going to write down the cents, but I'm keeping the number in my calculator, so I'm going to be perfectly accurate as I keep going. Multiply that by 1.2 and get 3583.18 times 1.2, 4299.82 times 1.2, 5159.78 times 1.2 gives us $6,191 Okay, now, just to be clear, all I did was the same investment as my first one. It's just that every 6 months I walked into the bank, took the money out, put it back in. What was the difference? The difference was instead of making $3,000, or sorry, I shouldn't say making $3,000, instead of having $3,000 at the end of the 5 years, I have $6,191.74, which I think is going to answer the question, which method builds money faster? It's definitely method two. And which method makes more sense for real life? I'm not going to write down an answer here, but I will briefly talk about it. And what it comes down to is it seems kind of silly to make people walk into a bank every 6 months and do this. And if it does work, then I would actually maybe go in every 3 months, maybe every month. Or better yet, if I'm going to make that much more money, I go in every day and do this. So in order to prevent people from doing oodles of ridiculous, redundant transactions, what the bank does is they do this for you. They basically treat your money and treat it like they're giving you interest on a regular interval so that you are always building money on your previously made interest. And they do it basically on a daily basis. Um, so that's where the compounding comes in. Now, of course, this is a very tedious way of doing things. So in tomorrow's lesson, when we look at actual compound interest, we're going to see a much faster, simpler way of doing this calculation, but we do have to modify our equations and change our variables a little bit. Just to go back and fill in the table here, in order to find out how much interest we made during each 6 months, all I have to do is take the amount that I have now and subtract off the amount that I had the month before. So 1728 minus 1440. So in the third block, I make $288 interest. And rather than make you sit there and watch me do this on my calculator or wait for me to do it on my calculator, I'm just going to pause, fill this in, and I'll be back in just a second. Okay, so there we go. There's the table filled in. Now, what I want to point out is that if we had done just straight simple interest like we did in method one, we would have made $200 interest during the first 6 months. We would have made 200 interest during the second 6 months, 200 interest for each of the 6-month blocks. So this would have been 200 all the way down. Instead, by the time we get to the bottom, we're not making 200 interest in the 6 months. We're making over $1,000 interest in that 6 months because we get to use all the previously made interest and get interest on top of it as well. So compound interest, definitely much more powerful for building up money than simple interest. Unfortunately, it's also much more powerful for building up money when you borrow money, and then it's not so nice. But it is unfortunately the way the world works. Okay, so you've got some practice problems there. You're basically going to do something that's very similar to what we just did as an example. Now this one looks long, but again, if you're paying attention and you look back to the example, you'll see that there's a very shortcut to do here. And so you can get all 24 of these entries pretty quickly. So this is just taking an investment and basically taking the money out and putting it back in every month for 2 years. Same as yesterday, there's only a couple answers there. These are the approximate answers. It's your job to find the exact answers, give or take a little bit of rounding error. If you need help, call me over. Otherwise, good luck.